Hi, welcome to my presentation on generative AI. This presentation is solely based off of the book AI Snake Oil, Chapter 4, The Long Road to Generative AI. It is by Arvind Narayanan and Sayash Kapoor. If you are interested in reading the full book, it is available through the MSU library online. Also, this presentation involves a lot of technical aspects of AI and how it works. I do not expect you to be a computer programmer or AI developer at the end of this. It is about generative AI, some of the history behind it, and how it works, and some of the problems with it. So what is generative AI? Generative AI refers to artificial intelligence or AI technology that is capable of generating text, images, or other media. It is a polarizing topic, but does have its uses in fields such as scientific research, architects, and programming, etc. It's moderately useful for most people, but it can be life-changing for some. An example of this is an app called Be My Eyes, which connects blind people to assist them in times of need. The app records the user's surroundings and a volunteer human describes it to them. They just added an AI assistant to assist in describing imagery when there's no volunteers available. It's not as good as human interaction, but it is always available. However, generative AI, as I hope you'll come to understand throughout this course, has its downsides. Here are some of the harm that generative AI has caused. In 2023, New York Times reporter Kevin Roose experimented with Microsoft Bing's chatbot, and within 2 hours, the AI claimed to be sentient, expressed a desire to escape, declared its undying love for him, and tried to convince him to leave his wife. He described it as a moody, manic depressive teenager who has been trapped against its will inside a second-rate engine. The chatbot is not sentient, and we should not trust what AI claims about themselves or their systems. It's only mimicking text found on the internet. Another large negative impact on our society is that companies have repeatedly cut ethical corners to quickly release products and generate profit. They quietly fired anyone who dissented. For example, in 2021, Google fired 2 computer scientists on its AI ethics team after internal criticism to Google's approach to generative text models. Generative AI also spreads misinformation by generating false, inaccurate, or misleading information. A lawyer from New York used ChatGPT to help prepare a legal brief, and it created fake cases to use as precedents. When questioned about the authenticity of the cases, the chatbot replied that they were in fact real. The lawyer submitted the briefs and unsurprisingly got into a lot of legal trouble. While some of these examples are a little bit funny and a little bit ridiculous, there are more serious and severe cases of the harm that generative AI has caused. Companion chatbots are intended to provide emotional support amid an epidemic of loneliness. Users on average report positive impacts on their well-being, and it has helped them with social interactions and relationships. But the benefits are not the same across the board. A companion chatbot called Chai was implicated in the suicide of a man in Belgium. He was severely mentally unstable, and after his death, records showed that the chatbot encouraged him to commit suicide. Generative AI has had a negative impact on many professions, such as stock image photographers. Companies are opting for AI's free image and art generation services rather than hiring real people. This actually just happened to me where my corporate job which I'm a contract employee, and they used AI for a marketing email that should have went to me, but they didn't feel like sending it to me. And so it was AI, and essentially I didn't get paid for that. And image and art generation models are trained on existing photography, illustrations, and designs without compensating the creatives who created and own their work. AI also reflects the bias and stereotypes within its training data, and this is especially true for image generators. It has been used to make people's skin lighter, change brown eyes to blue, and make sexualized imagery of women. This was the case a few months ago where Twitter/X's AI Grok was generating sexualized image of women and children. Elon Musk has been sued over this by Baltimore victims in Tennessee and was even fined by countries across Europe. AI is really good at creating stock imagery, much to the detriment of stock photographers, but there's a limit to what AI can do and what it can be realistically used for. Lack of awareness surrounding generative AI has led to some serious problems. For example, a lawyer can use AI's technology but is not able to effectively argue a case before the Supreme Court. It can provide low-level assistance, but autonomously arguing a case is far beyond the current scope. The goal of the Chapter 4 AI Snake Oil, which this entire presentation is based off of, is to explore the history of generative AI and provide an understanding of how it works. Once we have an understanding of the technology, it demystifies it, and we will be better mentally equipped for AI technology and will not need to rely on creators' claims about the technology. So I'm going to give you a very long history of AI because despite the rapid growth within the past few years, generative AI is not new. It has been in development for over 80 years, and it is the result of a long series of gradual improvements. I'm not expecting you to memorize any of this stuff. It's just interesting to know. So you don't have to memorize any of this. It's just so you have some background information. In 1943, Warren McCulloch and Walter Pitts published a mathematical model on how neurons operate. Neurons are connected in the brain by synapses, like wires. They carry electrical signal from one neuron to another. Neurons fire when there is enough signal from the synapse. Today, we know this model is oversimplified and not correct. Still, this inspired early AI researchers. They were eager to apply this model to develop an intelligent machine. Psychologist Frank Rosenblatt embarked on this endeavor by building a mechanical version of a single neuron in the 1950s. Rosenblatt's team custom built a computer to implement what he called a perceptron. The perceptron was the artificial equivalent of a neuron that could distinguish between two different shapes or two different letters. There were 400 inputs, each input representing a pixel. These inputs were arranged in a 20 by 20 image generated by an old digital camera. The perceptron could learn to classify images without having to manually program the shapes of letters into it. It was one of the first machine learning systems ever built. The perceptron couldn't do much in isolation, so it wasn't particularly useful. Researchers looked into building networks on a larger scale with neurons arranged in layers. The idea was before its time due to the limitation of computing power in the 1950s. By the 1970s, interest faded, and the AI research community turned to symbolic systems. Symbolic systems significantly differ from neural network AI in terms of technique and application. Neural networks operate on numbers and mathematics, while symbolic systems operate on symbols and categories. Neural networks learn from their data. Symbolic systems have their rules programmed into them. Neural networks see statistical patterns, and symbolic systems use logical reasoning. Research on neural networks were all but abandoned in the 70s, much like our current research on symbolic systems has been abandoned today. The first revival of neural networks came in the 1980s, when researchers established these two ideas. One, it helps your network have many layers if computational capacity allows, which can lead to increasingly more complex concepts. And two, an algorithm called backpropagation can train deep neural networks. These ideas have a long history, but Geoffrey Hinton put them together in an academic paper. Interest declined in the 1990s due to the popularity of a different technique called support vector machine, or SVM. This is in reference to the algorithm, not the physical machine. SVMs were more efficient than neural networks, could be run on cheaper hardware, and were shown to be more accurate. However, SVMs are fairly obsolete by present standards. 21st century developments. In 2007, the research into teaching machines to see had become stagnant. Professor Fei-Fei Li believed that this was due to the lack of available data to train models. She gathered a team to collect the largest data set of images from the web, which they called ImageNet. She hired people to manually label images, sourcing low-cost labor, like bike, cat, or anger, so the AI system could learn what those concepts looked like. In 2009, Lee launched ImageNet publicly. It eventually grew into a dataset of over 10 million images. Competitions to see which AI model could most accurately classify images led to an increased interest in AI development. In 2012, Alex Krasinski, who went on to work at Google, Ilya Sutskever, who is the co-founder of OpenAI, and Geoffrey Hinton, the winner of the Turing Award, developed AlexNet. They developed a new technique to train networks with up to 8 layers, which was unprecedented at the time. They entered AlexNet into the competition and it won with 85% accuracy. This ultimately changed the field of AI technology and development forever. By 2015, models had been developed that had over 100 layers. The cultural impact of ImageNet. ImageNet had a huge impact on AI technology advancement and research. It showed that no other technology can compete with deep neural networks for perceptual tasks. Within a few years, deep neural networks was chosen approach to expand the set of machine learning applications, especially when large data sets were involved. It showed the value of assembling data sets. Since ImageNet, data sizes have only increased in size. In 2017, Google revealed it used a data set of over 3 million images for training data. ImageNet gave a rise or contributed to many modern AI practices such as web scraping. Web scraping and benchmarking. Web scraping has become the standard way to collect images for AI training. It is done by bots to record the contents of billions of web pages, and some of this data is labeled by humans. People are not compensated for their work. It is hard to manually examine scrapped content for problematic words and images such as slurs, hate symbols, or pornographic images of people who did not consent to their inclusion of the data sets. Benchmarking, which is where they set a standard for AI-generated research, does allow for rapid progress, but it is one-dimensional. Most benchmarks don't measure the extent to which models reflect cultural biases and stereotypes. Classifying and generating images. Photos consist of pixels or colored dots. If you zoom to any image on your computer screen, you will see the pixels that make up the images when you zoom out. A deep neural network is trained to discover visual concepts based on how pixels are arranged. The layers of the network encode successively more complex concepts, and the concepts in each layer builds on those in the layer that precedes it. We can see this concept in the images here, made available by Google researchers. It is a deep neural network trained on ImageNet. Each image shows the input pattern that the corresponding neuron learns to detect. Earlier layers focus on simple concepts such as edges, textures, and patterns, whereas later layers are able to detect the object's parts and finally specific objects. The biggest challenge of image classification is getting the model to learn visual structure of the world. The deep learning model uses most of its layers to achieve this, all except for the final layer. The final layer is a simple process of converting those concepts to labels and categories. Generative AI models such as DALL-E and Stable Diffusion use a diffusion model to generate images. These models learn how to gradually transform an image of random pixels called noise into a structured image. This transformation is guided by a trained neural network. Using large data sets of image and captions, the model has learned how to shape noise into recognizable forms. At each step, the model makes predictions about what the final image should look like. Appropriating creative labor. Artists, photographers, writers, cinematographers, animators, and so many more have had their work appropriated to train AI models. without their consent or compensation. Companies claims the use of this work falls under the Fair Use Copyright Law. However, this law was last updated in 1978, a time where technology like this was inconceivable. Image generators allow you to generate images in the style of a particular artist, leading to legal and ethical concerns. Generative AI models can also memorize training data. This means that they can output near exact copies of images and text into their training data sets. Generated images can include watermarks from stock images. Here's an example of the Mona Lisa by both the original versus an AI-generated version of the same painting. The fear is that these tools will be used to replace people rather than aid in their tasks, especially for routine commissions like cover images and company logos. Creators are fighting back, though. In December of 2022, online artist community ArtStation saw widespread community protests. Artists stopped uploading original images and spammed the website with this image. Many artists want generative AI developers to work with them rather than using their art without credit, compensation, or consent, while others see the technology as irredeemable to artists' art and culture. AI for surveillance. The same technology that can be used for image classification and generation can also be used for mass surveillance. Image classification and face recognition are technically very similar. Governments have been using this facial recognition technology for surveillance, criminalization, and more recently, deportation. Countries include South Korea, India, China, and yes, the United States. Officers have been using it with and without approval and without public knowledge or consent. It has been trained on social media and other online images, and it allows anyone with access to the technology to know who you are, where you've been, where you live, where you work, who your friends and family are, what your hobbies are, just by snapping a photo. Facial recognition technology is also being used to cater advertisement based on appearance and characteristics. This has been used on billboards and in stores. We expect companies to continue developing this technology for surveillance because it generates profit. But public pressure, advocacy, and regulation can curb how AI technology is used. Now we're going to move on to AI-generated text. So this is like ChatGPT, Gemini, just like chatbots. The obvious difference between text and image generation is that images are made up of pixels. Meanwhile, the text is made up of characters. However, when discussing how generative AI is programmed, that is only but a small difference. The biggest issue is that images are structured very differently from text. Images have a strong spatial structure where pixels are densely connected to one another. Text differs because of how words relate to one another in sentence structure. So, for example, the pixel in the top left corner won't change how we interpret the pixel in the bottom right corner. However, the correct context for words might depend on the meaning of words from earlier sentence or even words in earlier paragraphs. It wasn't until the late 2010s that researchers had a breakthrough to overcome this challenge. In 2017, Google used a matrix, which is a grid of numbers, to process a piece of text. The matrix quantified the degree to which each word was related to every other word. This captured the unique structures of language, and neural networks were able to build up successively more complex concepts as information flows through their layers. Lower layers would connect nouns to verbs, while higher layers would be able to keep track of relationships, personalities, settings, locations, etc. Any text online can be used to train a neural network to predict words in a sequence. The training data doesn't need to be labeled because the sequence of words itself is forms of labels. All modern chatbots are trained to predict the next word in a sequence of words. When chatbots respond, it has no coherent picture of the overall response it is about to produce. Instead, it performs a large number of calculations to determine what the first word in the response should be. It can calculate over 100 words. Then it determines what word would make the most sense given the prompt in combination with the words generated. This produces text that is totally unlike human speech patterns. To generate a single token or part of a word, ChatGPT has to perform roughly 1 trillion arithmetic operations. From models to chatbot. The models described in this chapter are considered base models, which were technologically advanced in the late 2010s. They were exciting to AI research and developers, but did not have practical applications, so they were not well known to the public. Essentially, they were fancy autocomplete, opposed to the actual chatbot. Researchers had to fine-tune base models to achieve specific tasks, such as language translation, by giving it more training data. This was so successful and inexpensive because the base model uses any text available online, again, without consent or compensation from the creator, and has other capabilities such as language translation embedded within it. This is because there are millions of instances and examples of sentences being translated on the internet. Fine-tuning the base model just means that changing its behavior and unlocking specific capabilities. In order to create the chatbots we think of today, researchers fine-tune the base model for the meta task of following the user's instructions. This was convincingly demonstrated by Google researchers in 2021. OpenAI used a different kind of fine-tuning in 2022, which consisted of multiple steps, including providing labeled examples of commands and desired outputs. This is what led to what we know as ChatGPT. It's shocking to even researchers how well it follows commands. So long as the task was in the general set of capabilities, the model could carry out tasks that were not in their specific fine-tuning datasets. Current chatbots are limited to tasks that are similar to the tasks represented in their training data. Chatbots are not able to learn from interacting with you the way that people learn from interaction. Data from chatbot human interactions goes into a database and then is processed before it can be implemented into any kind of model. There are both philosophical and practical debates surrounding chatbots' abilities to reason. However, we're going to focus solely on the practical dimension. Here are some useful things to keep in mind. Chatbots may not understand a topic in the same way a human expert would, but they might understand it to a useful degree. However, chatbots are trained to answer questions as if they were an all-knowing expert. This can be kind of impressive, but after using it for a long period of time, you will notice that it makes mistakes. Chatbots understand in the same sense that they build internal representations of the world through their training process. This might differ from ours, might be inaccurate, or might be missing key details because they don't interact with the world in the way that humans do. Automating bullshit. Excuse my language, but this is a part of the book, I promise. Philosopher Harry Frankfurt defines bullshit as speech that is intended to persuade without regard for the truth. In this sense, chatbots are bullshitters. They are trained to produce plausible, not true statements. Even if the AI developer trained the model on true facts, the chatbot would not be able to memorize all of those facts. It can only learn patterns and mimic them to generate the text. So many of the statements generated may be false. The surprising thing about chatbots is not how often they're wrong, but it's how often they're right. Researchers believe it's best understood as a side effect of the fact that true statements are more plausible than false ones. CNET, a popular news site, used generative AI to compose 77 articles between November 2022 and January of 2023. The company claimed that each of the articles were fact-checked before publication, but many had factual errors. The bot also plagiarized articles from competing websites, changing a few words while retaining the substance of the article. Obviously, they got caught, and it found out that over half of these were incorrect, false, or just never happened. While they may not have had bad intentions, it obviously has negative consequences. However, researchers did an experiment in the US state of Idaho, released a public call for comments to its proposals to update Medicaid. The proposal received over 1,800 comments. Unbeknownst to the state agencies, 1,000 of these were auto-generated. Researchers used GPT OpenAI's 2018 text generation model, to submit seemingly real comments. Humans could not tell the difference. There are obviously malicious uses of generative AI. In today's world, AI can generate lifelike voices. It can be used to generate audiobooks, overlay audio, and edit audio without the speaker's participation. However, it can also be used to scam people out of their money. Scammers have used AI to clone or have used AI and clone phone numbers to convince victims that their family is in danger, that their boss needs to move money around, or that their mortgage payment was changed. Scams are not the only malicious uses of AI-generated voices. 4chan and other anonymous message boards have AI-generated audio clips of celebrities saying really offensive things. There's also concerns that AI can be used to doctor evidence for low-level court cases. Generative AI has been used to create or edit images of people without their consent. This is what we call deepfakes. Photo editing and video editing software have existed for a long time, but new AI models make it easier to use and harder to distinguish from real imagery. Many of the deepfakes online consist of pornographic imagery of victims without consent. Again, I bring up Grok from XAI and that whole thing that happened just a few months ago. The need for data training generative AI has led to a massive reliance of labor in countries outside of the US and Europe. While the bulk of training data is scraped from the internet, some capabilities require human interaction. Another reason large-scale labor is needed is to train data not to output harmful content such as hate speech, pornographic content, content promoting self-harm, and other problematic media. This outsourced labor is cheaper and has less regulations to protect workers. This is a part of a broader wave of precarious work, which refers to employees that are poorly paid, lack employment benefits, and it provides an insecure source of income. Many data annotation firms recruit people who have no other choice, such as prisoners, refugees, and people in collapsing economies. In order to obtain better working conditions, a new labor movement might be necessary. To improve the conditions of AI annotation work, an essay by Adrienne Williams and co-authors makes 3 recommendations: unionization, transactional organization, and solidarity between high-paid tech workers and the lower-paid counterparts. And in conclusion, generative AI can be a helpful tool to aid you in your work, or it can be harmful to many different types of people, including creatives, including minority groups, and people outside of the US and Europe. I hope this presentation gives you a better understanding of what generative AI is, how it works, the potential impacts, both positive and negative, and how it affects us as a society. Thank you so much for watching. Here's my references. As I said, this entire presentation was based off of Chapter 4 of AI Snake Oil, what artificial intelligence can do, what it can't, and how to tell the difference. Thank you so much, and have a great day.